In this lesson, we'll be discussing graphing inequalities, and you'll see that I have a couple inequalities already started. In the first one, we notice that it resembles slope-intercept form, where the slope is -1, so down 1 and over 1, and the y-intercept is at 0, 3. So I start at 0, 3. I went down 1 over 1, down 1 over 1, and maybe even up 1, left 1. What you'll know about the graph and how it differs from if it was an equation is that we are now going to shade. Since we notice that this inequality says we want where y is less than that boundary, we will be shading the graph where y is less than the height of the line. You'll also notice that the line is dotted. Whenever you have less than or greater than, you will use a dotted line. Whenever you have less than or equal to or greater than or equal to, you will have a solid line. You'll notice that this is kind of similar to the ideas of open and closed circles like you used before. It gets a little bit more complicated in the bottom problem because we're using the cover-up method to get the x-intercept and the y-intercept. And we're going to graph, but since y is not alone, we cannot just use the trick to go ahead and shade above it. In class, you're going to learn about testing a point. So I'm going to test the point 0, 0. That would be right where this asterisk is. And I'm going to plug in a 0 for x and a 0 for y at the exact same time to test to see if this is true. 0 plus 0 is 0, and 0 is not greater than or equal to 8. So where that point is a false statement. So I cannot shade there because the opposite is where it would be true, and we only shade where it's true. Good luck on this lesson.